Hello, pre-calculus students. Today we're going to talk a little bit more about transformations of functions. Let me share my screen with you and we'll get started. So this part should all be review. Whenever we replace x with x minus h in a function, we're going to translate the function h units to the right. So if it's x plus h, that's the same as x minus negative h, so that would move it to the left. Same when we replace y with y minus k, it translates our entire function k units up, and if it's y plus k, that would be the same as y minus a negative k, that would move things down. So if we take a look at the graph of y equals x squared, and I'm not going to graph it, you know what y equals x squared looks like. You can see that I've replaced x with x minus 2 and y with y minus 3. So what that should do is that will take the graph of y equals x squared. It will move the whole graph 2 units over to the right and 3 units up. Now, usually we don't write a function like this. We would set the independent variable all alone. So we'd take this negative 3 and add it to the other side. And here you can see that it absolutely does raise everything 3 units. When we replace x with negative x in our function, you're reflecting around the y-axis. Quick review question. What type of curve, or what type of, well, let me rephrase that. We have odd functions and even functions. Which one is symmetric about the y-axis? Look that one up if you're not sure. But you can take any curve. I mean, this doesn't necessarily make it symmetric about the y-axis, but it does reflect the curve across the y-axis. And if the curve looks exactly the same as it did before you reflected, then it is symmetric about the y-axis. And when you replace y with negative y, you take a positive y value and make it negative, or vice versa. It's really like you're just multiplying the entire function by -1. So all those positive y values become negative, negative y values become positive, and you're reflecting across the x-axis. Now, a couple of definitions that might help us understand things. We have rigid and non-rigid transformations. The rigid transformations are where we translate or reflect a graph. Non-rigid ones are where we actually change the shape. And normally we'll change the shape when we're stretching vertically or even horizontally. But here, if a is greater than 1, we're making all those y values a times as big. And if a is between 0 and 1, you're making all those y values smaller. So rigid versus non-rigid. Are we changing the shape or are we just moving the curve? And lastly, we're going to go over all these in our in-class instruction. I'll just put them here so you can write them down. Here are a bunch of functions that we are going to graph in class on the computer so that you can look at them and see that the changes that we just discussed, replacing x with negative x, or replacing x with x minus h, for example, you can see the changes happen as we make them. So please write these equations down. Going over these equations might take a while, but this video sure didn't, because we're done with the video. Have a great day.